Hello, this is another video on chapter 11. So I want to finish the chapter in this video. I hope you're doing well. So let us get started. So I'm going to continue with where we left off last time. So we want to talk about series. Last time we talked about sequences, and we're going to talk about series. So the series are nothing but sums of sequences. So if you take any sequence, you know what the sequence is. We talked about it in the previous video. So if you take a sequence and add all its terms, then you get a series. And for series, we use the notation, sigma notation. So we need to know this notation. Sigma is a Greek letter, of course, and is a capital letter. The lowercase letter sigma looks like this, and this is the capital letter sigma. So what we do basically, what comes after it, whatever comes after it is a formula of the sequence that we are actually adding or summing. So if you put a sub n here, and then put n goes from 1 to whatever number, it could go to infinity if it's an infinite series, then you get a series. So you see, this is a sequence. So we can expand this sequence just like we did in the previous video, from 1 to infinity, and then add them. Instead of putting comma between them, we put addition. So this is going to be A1, right? And then there is A2. Now if we had a sequence, we would just put comma between them, but now we put summation, and then dot, 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 all the way to infinity, of course. And then we would do, of course, A sub n, right? You know, that's how you find it, whatever n is, and then plus dot, dot, dot. So that's a series, and that's an infinite series. So this number, of course, is the upper limit of the summation. This is the lower limit, index of summation. This is lower, this is upper, the numbers, and then the letter, of course, is the index. This is also, this is also a k equals to 5, this is k equals to 1, but we don't put that k up there, we just put k equals to 1 to 5. And this index of summation is the same as the variable that you have to use in the formula, because you have to substitute these numbers into those variables, right? This is just one variable. And then we could also have more of these. You can have several of these, right? Triple summation, double summation, but we're not talking about that. We're talking about only one summation. Okay, so that's what the series is. So let's look at an example. So this is 2k. So you can think of 2k as being what? A sequence. See, we have different notations for sequence. We can represent it like that, or you can represent it like a sub k is 2k, right? So these are different ways. Or you can write f of k equals to 2k, right? These are all sequences. So inside here we have a sequence that we have to add instead of putting comma in between. And then the way we do it, of course, just like we did in the previous video, just substitute these numbers for the variable, and you get different terms. These are, of course, this is the first term, the second term of the series, and so forth. This is a finite series because it ends right here, and then you add them. Okay, so here is an example. So to add this, we start from 3 and we go to 7 for this one, because that's what we are told to do. So k equals to 3 gives you the first term, and then k equals to 4 gives us the second term, and so forth, right? So here we have 5 terms we have to add. And we get 135. Now we could do this with the calculator as well. So if you do it with the calculator has 3 modes, or even more, 4 modes. So if you go to mode, you see the calculator has function, parametric, polar, and sequence. Normally the calculator is on function. So we're gonna go to sequence and press enter. So it switches this to sequence. When you press y equals 2, of course we talked about this in the last video, we can now put this function, which is, let's do this one, which is that's the sequence. We put the sequence here. So let's, and we have an explicit formula, so we could just put the sequence there. It's k squared, so we put n squared, right? And we don't have to put anything there, because this is not what? This is not recursive formula, it's explicit formula. And then we start with whatever number you like, right? So that number is 1, so we're going to start with 3 here, right? It doesn't matter where you start here, because that's the sequence. So we get out of here. In fact, you don't have to put it in y equals 2. I just showed you how to do it. So to add, we have to create the sequence and then add it. So we can do it in many different ways. One way, of course, is using this. I'm not gonna use that even. You could just go to second list and go to operations and get the sequence, number 5. And then I'm just going to put the formula in here, n squared, and then comma n, and then comma. Now I want to expand this from 3 to 7. So I'm going to go from 3 to 7, right? So what the calculator is going to do for us is going to basically give us the sequence of what? Of these numbers, right? That we have to add. It's going to give us these numbers. So press enter, and here you go. See, those are the numbers that we have here. So now we want to add these. All you have to do is go to second list, and this time you go to math and go to number 5, sum. And then we want to sum this sequence. The sequence is the answer. So that's 135. Okay? So that's how you do it with the calculator. Some calculators actually have this. So some calculators have this notation. There is a little thing box here, there's a box here, and there's a box here. You can fill in, and then it gives you the summation. So that's not a problem. We don't do these things by hand. You just understand the structures in order to understand the concept and build more on those concepts. That's why we learn these. Otherwise, nobody is going to pay you in the market to calculate these by hand. All right, so sum of first n terms of an arithmetic series. An arithmetic series is a series that what? Inside has an arithmetic sequence. You know, arithmetic sequence was given by a1 plus what? Plus d times n minus 1, right? So if we have something like that, can we get a formula to add it so we don't have to every time, you know, create all the terms and add them? And the answer is yes. So this was done by a mathematician called Gauss. Supposedly, when he was 10, he was told to add numbers from 1 to 100, like that. So, you know, this is a lot of work. So you have to write 100, 99, 98, 97, 96, all the way to 1. You see how much work is this for a 10-year-old? So supposedly in his class, he was the only one who actually did it correctly. So we assume that he did it this way. So he wrote it in the opposite direction, in the opposite, kind of like that, the other way around, from largest to smallest. So the last one is 1, and when you add, so what he did supposedly, he added these, and he got all 101s, right? So how many 101s do we have here? Well, we have this many, 100. So 100 101s, if we multiply, we get the sum, but that is the sum of 2 sets of these numbers. So basically he divided it by 2. That's the sum. You could do that in a few seconds, but if you want to do this, it takes forever. And you can make a lot of mistakes. Here there is a multiplication and division. That's an easy thing to do. So let's do basically the same kind of thing that supposedly he did. So we write the terms of a arithmetic sequence, and then we write it in reverse order, and then add them. So what happens here? We get what? We get a1 plus a sub n, a1 plus a sub n, and so forth. And the d's, right, get cancelled, right? The d's get cancelled. So what we are going to do is so why are we subtracting here? Of course, why are we subtracting here? a1 plus d, a1 plus 2d, and all the way to what? Now, right before a sub n is obviously a sub n minus d, because how do we get this one? We have to add d to the previous one, right? So the previous one is d amount less than this, because to get a sub n you have to add d, right? So on this side you can think of addition, adding to get a sub n, and here we can think of subtracting from the right to left. To get the next number we have to subtract d, right? So first we start with a sub n. To get the next one we have to subtract d. To get the next one we have to subtract 2d's, right? Because we're starting from the right hand side. And now if we add them, we end up with a1 plus a sub n and so forth, because all the d's get cancelled. Now how many of these do we have? Well, we don't care how many, we just want to add them. So we add them and divide by 2, and we have the answer. How many do we have? Well, from here to here, we start with 1, we go to n, that's n of them. So we have n of these, right? And then we divide by 2. So that's the formula to find the sum of an arithmetic series. That's how we add it. So basically add the first term and the last term, take the average of them, and multiply by how many we have, right? So if it's arithmetic, now arithmetic, remember, not any series is arithmetic, it has to be arithmetic. Let's say I start with 1, I keep adding 3, right? So that's arithmetic. So if I want to add these, the formula says just add 1 plus 13, right? And then divide it by 2. Then multiply by how many numbers we have, which is 5. 1 plus 13 is 14, divided by 2 is 7 times 5 is 35. 1 plus 4, 5, 12, 22, 35. That's correct. So basically we take the average. So we think the average of the first and the last term is 7. So we are going to think that we have what? We have 5 sevens. 5 sevens, right? And we add them. Okay, so that's the idea. So here is an example, several examples. First one, well, that's easy. You just count how many numbers we have, add 5 plus 32, right? And then divide by 2 and multiply by that. 10. We have 10 numbers. So it would be 10 times 5 plus 32 divided by 2, 185. What about the second one? Well, second one, we do have the first one, and we do have the last term. The only thing that is missing here, and we know there is a 2 here, how many numbers do we have here? Right? So since it's arithmetic, we know in arithmetic sequence, if these plus signs are commas, that would be arithmetic sequence. In an arithmetic sequence, let me show you the answer, then I'll explain it. So in arithmetic sequence, we have, here's the answer, here's the question. So a sub n is a sub 1 plus n minus 1 times d. So here, a sub 1 is 20, right? That's 20. And d is 15 minus 20, 10 minus 15, right? So d is negative 5. So in this formula, we have everything. Now we also know that negative 50 is a sub some n. We don't know what n, but we know this is a sub n that we are looking for. So we're going to put it for a sub n, knowing that, of course, we don't know what n is. And then in this formula, we solve for n, which is 15. So that means this number, this position, is the 15th position. Why? Because n equals to 15. And remember, n is the position number, right? Because we start from 1. All right, so now that we know what that n is, we put it there. That was 20 plus negative 50, which is 20 minus 50. So that's the sum. And the third one is easy because we have a summation notation. So A1 is when k equals to 1. So A1 is going to be what? We put the 1 in here. 3 times 1 is 1. 3 times 1 is 3 minus 8 is negative 5. So that's our A1. And A sub 12, because that's A sub 12, is when k equals to 12 is going to be, well, we just put 12 in there and we get 28. And there n equals to 12, of course. So in this formula, we have everything. We put it in there and we solve it, right? Let me clear that mess I made. So 12 times negative 5 plus 28 divided by 2, 138. All right. A man earns $100 in the first week. Each week he earns $12.50 more than the previous week. How much has he earned in week 12? So this is a progression that is arithmetic. So we want to find the sum of an arithmetic progression or sequence. So it's so we need to find what? We need A1. We need, oh, it's right here, right? So we need A1. What is A1? Well, A1 is the 100 that it starts with. Now, what is A sub n? Well, week 12. So we have to find A what? A12. What's A12? But, well, we have what? We have the first term. So we rewrite the formula. So we know the formula is A1 plus D times n minus 1. A1 is 100. And what is our D? D is 1250 we add every time, right? So D is 1250. So now we can find A sub 12 using the formula. That's 237.5. So that's 237.5. And now n, of course, is 12 in this case. And we have $2,025. Okay. And on the Sunday after a minor surgery, a woman is able to walk a half mile. Each Sunday, she walks an additional quarter mile. On week 8, what will the total number of miles she has walked? What will be the total number of miles. Okay, so in this case, again, the formula is given. So this is a sum, but inside here we have an arithmetic what? Arithmetic sequence, right? That's what we have here. So we want to find this from n equal to 1 to 8, right? And we know how to do that because we have a formula. That would be 8 times A1 plus A8 divided by 2. We don't have to expand it because we have a formula for it. All right, so do we have the first term? Yes, the first term is half a mile. So we are given that, right? Right here. So that's the first term. Plus, what's our D? Well, it says right here, she walks an additional quarter mile, right, every week. So that's 1/4. That's our D. So all we need to find is A1, which is that. We have that. And then we have to find A8, or A sub 8. A sub 8 is 1/2 plus 1/4 times 8 minus 1, which is 9/4. And that's it. So the answer is 11. Okay? All right. And what about geometric series? So we talked about geometric sequence. A geometric sequence is given by A1 times R to n minus 1, right? So what if we want to sum from, let's say, A1 R to n minus 1. Let's make this k minus 1. So we can make this k from 1 to n. So, because if you use the index here, you can't use the same thing over there. So we change it so we can go to a number that we don't know yet. Okay? So this is called S sub n, which is what? Which is the sum of the first n terms of a geometric sequence. So the question is there a formula for that too? And the answer is yes, but we have to work on it a little bit. The same trick doesn't work. If you put this in the reverse order, add, you don't make it simplify. You don't make it simpler. So what we have to do is multiply both sides by r. So multiply this side by r and multiply this side by r. So it would be a1r plus a1r squared plus a1r to the third plus dot 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 plus. Now, it would be a1, let me write the last one first. So it would be a1r to n, right? Because r to n minus 1, right, times r to first, when you add these two, you get r to n, right? So this one becomes r to n. But what about the one before that? Well, the one before that is r to n minus 2, right? a1 r to n minus 2, right before that. Because you have to keep, adding 1 to get to n minus 1, right? You see r to first and then to the second, then to the third, right? So what happens with that one? Well, that one turns into what? If you multiply it by r to n minus 2 times r to first is going to be r to n minus 1. So that one becomes r to n minus 1, right? Okay, now we are going to subtract these. So Sn minus r Sn equals to, so I subtracted the left sides. Now think about it. If I take this and subtract this from it, all of these become negative, right? All of these become negative. So there is no a1 here, right? Because we multiplied by r, we don't have a1 here. So A1 survives, but everything else gets canceled, right? So there is a 3 here that is going to get canceled, that one. And then this one cancels this one. And we don't have a R to N over there to cancel this one. So minus A1 R to N also survives in this subtraction. So on the right, we just end up with this. Now factor Sn on the left, we get that. And factor A1 on the right, we get that. So remember, we wanted to find S of n is going to be A1 times 1 minus R to n over 1 minus R, right? So that's a little too long, but there. So that's the formula to find what? To find this sum. So this sum here, which I wrote right here, see that? Is equal to A1 times 1 minus R to n over 1 minus R. Right? And remember, we started with this form when k starts from 1 and the power of R has to be k minus 1. If we have this structure here, then if you want to find the sum from 1 to n, that's the formula. Okay? All right, so let me clean this mess and show you the work was right here. That's Sn. And here is a better looking one. So Sn is going to be that. R is not 1 because if R is 1, denominator is 0, so it doesn't work. And we don't want R to be 1 because if R is 1, that means these numbers are all the same, right? We don't need a formula to do this. You just multiply by whatever number you have times that number, right? So R equals to 1 doesn't work, and we don't really need it. All right, so I hope the audio is okay here. So here is an example of, let's see, look at an example here, two examples. We got A and B. So in A, we are given a series that is infinite. See, dot, dot, dot means goes forever. And then we have S11. That means find the first 11 terms, right? All right, now to do this, well, we don't want to write them down and then add them. That's not it's not going to work. What if they say find S11,000? Well, that is not going to work for you. And by the time you finish, they add another 0. So we need a formula. So the formula, first of all, we have two formulas. We have formula for arithmetic, right? And we have formula for what? For geometric. So if it's not one of these two, then we can't do it with formulas. Is this geometric or not? Well, let's see. If we divide, what do we get? Negative 4 divided by 8 is negative 1/2. What is 2 divided by negative 4? That's also negative 1/2. So our R is actually negative 1/2 here. And it is geometric, right? So R is negative 1/2. And A1 is 8, right? What do we need to find the sum? We need R and we need A1, right? And we need how many? N. So S11 would be basically 8, which is the first term, times 1 minus R to the 11th over 1 minus R, right? That's that formula. We can use a formula or use a calculator to do this, right? You could also put the formula for the sequence in the calculator. The formula for the geometric sequence is what? is A1 R2 n minus 1, right? So it would be 8 times negative 1/2 to n minus 1. So you put that in the calculator in the sequence feature, and then comma n, comma 1, comma 11. And you can find this sequence and then you sum it. You can actually put it in one expression like this in the calculator. And where are the sum and the sequence? They're on their second list, right? We did that already. All right, what about the second one? Well, the second one is already in the form that we can easily do it, except for, remember we said what? We said that the structure has to look like what? Has to look like this, right? It has to start from 1. It can go to any number. And then here we have to have A1R to K minus 1. Now, does this look like that? No. This is fine. It starts from 1. But this is not fine because this is not to K minus 1. So how do we make this K minus 1? Well, we can take 1, 2 out of it, right? Because if you take 2 times 2 to K minus 1, you see the powers are what? If you add the powers, you get what? You get 2 to K. So 2 to K is like 2 times 2 to K minus 1. So if we make that modification, then we are ready to, so there is a 3 there, then we have to take a 2, and then 2 to K minus 1. Now these two give us what? Give us 6 times 2 to K minus 1, and K goes from 1 to what? To 6. So our A1 is 6, and our R is 2, right? And again, to use that formula, that's all we need, right? So here we go. Let me clean that mess. So now we know A1 is 6, and R is 2, and N is 6. And that's the formula, 378. Again, you can, for the sequence, to use the calculator, you don't have to change the form or anything. You could just put this thing as the formula for sequence and then go from 1 to 6, because you're not using a formula in the calculator. You're just adding them. Now here we were using this formula, right? Okay, so that's geometric. Here's another example. So what we have here is at a new job, an employee's starting salary is $26,750. He receives a 1.6% annual raise. Find his total earnings at the end of 5 years. So we want to add all the money that this person makes in 5 years. So the first year starts with that, but the next year is going to be that plus what? Plus this percentage of it. So you see, this is the original amount plus, if you want to find this percentage of this, then 1.6% is actually what? 0.016. So we have to take 0.016 and multiply it by that thing and add it to itself. So that would be the original 1 times 1 plus what? 0.016, which is the original amount times 1.016, right? So that means we start with this and we keep adding what? 1.016 of it, right, to it. So this is the first year. The next year is going to make what? It's going to make 26,750 times 1.016. And the next year after that is going to be 26,750 times 1.016 to the second power, right? because you have to multiply this again by 1.016, and so forth. Now we want to add this series, which is a geometric series. So if we were to write the formula for it, it would be 26,750, right, times 1.016 to the power of k minus 1, and k starts from 1 to whatever number you like. In this case, we want over 5 years, right? So we want to basically sum this series. And to sum this series, we can use the formula, right? And the formula is, again, right here. So we just put those numbers in there, and we get $138,099.03. Okay? So that's that. Now, the sum of an infinite geometric series. Here's something very interesting. You see, when we use this formula to sum, what if n goes to infinity? Can we add infinite number of terms? Well, it turns out that it's possible to do that if this r is between 0 and 1. That means it's a fraction. And the reason is this. This part right there, let me explain it right about here. So that part right there, if r is a fraction, let's say r is 1/3, right? What happens to that part? Well, 1/3, and instead of n, let's say is infinity. So it would be 1 to infinity, which is 1 in our purpose here. And then the denominator would be 3 to infinity. Now, so 3 to infinity is infinity, so that just goes to 0, right? So that means if n goes to infinity, this part goes to 0. So what happens to this formula if that part goes to 0? So it changes to just a1 times 1, which is just a1, and then 1 over 1 minus r. So we have this formula. It means that if r goes to infinity, then the formula to find all the infinite number of terms is just a1 over 1 minus r. Now this works only if r is a fraction, right? Otherwise, it's going to go to infinity. All right, so that's the idea. So can we apply this idea to find this sum? 1 plus 1/2 plus 1/4 plus 1/8 plus 1/8, and keep going, right? Can we add all of these together? Yes, because this is a geometric series and is infinite, and we know a1. And what is r? Well, r is 1/2 divided by 1, 1/4 divided by 1/2, 1/8 divided by 1/4. And looks like r is 1/2. If you do that, you get 1/2. So r is 1/2, and a1 is 1. So the sum of this series would be 1 divided by 1 minus 1/2, which is 2. Can you believe that? If you keep adding, this is just amazing what happened here. I don't know if you realize. You're adding what? Infinite number of terms, no matter how small they are, your infinite number of them. But by the time you finish, you just get 2. Now, if we still don't get 2 until you finish all the way to infinity, which is never possible, right? So you get something close to 2, but you never get exactly 2. But the sum, the limit of the sum, and that idea you learn in calculus, the limit of this sum is 2. When what? When the number of terms go to infinity. All right, so we can add infinite number of terms of a geometric series. All right, so I got that already. So determine whether we can do this for these series. First one. Now this one is not even geometric, right? Because when you divide, you don't get the same number. 8 divided by 12 is not the same as 4 over 8. So the first one is no. Okay, what about the second one? Well, the second one, the answer is yes, because, let's see, 1/2, first of all we divide. 1/2 divided by 3/4 is 1/2 times 4/3, which is 2/3. And then 1/3 divided by 1/2, 1/3 divided by 1/2 is 1/3 times 2/1, which is 2/3. So that means the ratio, the common ratio is what? Is 2/3. So R is 2/3, and it is geometric. Since it's geometric and R is 2/3, then it's possible to add this. In fact, it would be 3/4 over 1 minus 2/3. That would be the answer. Would be 3/4 divided by 1 minus 2/3 is 1/3. So the answer would be 9/4. That would be the sum of all of these. But that was in the question. We didn't have to actually find the sum. The question is, can we do it? Is the answer finite? Is it defined? Yes. Okay, what about the next one? Well, the next one is obviously what? Is geometric. And so we can actually do this. Now, notice that we can't apply the formula the way it is, because this is not what? This is not A1, right? Why? Because this is not K minus 1. So in order for this to work, we have to write this in this form if you want to actually apply the formula. You can apply it, it's defined, but the way you do it is you're going to take 1/3 out of here and then write it as 1/3 to K minus 1, and that would be 27 times 1/3 is 9, and that's 1/3 to K minus 1. So now we know A1 is 9 and R. So that would be S infinity right there. Make sense? All right. And what else? One more. Now this one is not defined because it's not geometric for sure, right? So the answer to that one is no. We can't apply the formula. A deposit of 100 is placed into a college fund at the end of every month for 10 years. The fund earns 9% compounded monthly. How much is in the account right after the last deposit? So this is basically 100. You start with 100. Then the next month, right? 9% increase. Now 9% increase is not per month, it's per year. So how much increase is per month? Is this much increase, right? So that means first you start with 100 and then this much of it is added to it, right? So this would be next month. So what is that? Well, that's 100, if you factor 100, times 1 plus what? 0.09 over 12, right? And then that would be the next month. And the month after that would be to the second power and so forth, right? So it's going to be, so this would be, next month would be this much. A month after that would be that much. The month after that would be that much. And this goes inside the parentheses here, right? So that is what? That's a geometric sequence. And then since we add them, is a geometric series that look like that. There's a 100 starting with, and then we got 1 plus 0.09 over 12 to K minus 1. And K starts from 1 to, let's say, whatever you like there. All right, so how much is in the account right after the last deposit? Well, you're going to do it for 10 years. 10 years has 120 months in it, right? So we have to go from 1 to 120, right? And that is, of course, we can use the formula for it. So let me show you the answer quickly. So we get the A1 and 1 minus R to N over 1 minus R. So now you can actually use a calculator and find out what that is. What is 0.0, what is 1 plus 0.09 over 12? What is that? Well, that is 1.0075. So for R, you can put that, right? And we have a formula, and we get $19,351.43. Okay? So that is that. All right, now we're going to move to a concept of counting principle. These are very useful in probability, in statistics, and in other branches of mathematics. So let's look at the first counting principle, which is addition principle. If one event can occur in m ways and a second event with no common outcomes can occur in n ways, then first or second event can occur in m plus n ways. For example, a student is shopping for a new computer. He's deciding among 3 desktop computers and 4 laptop computers. What is the total number of computer options? So he's going to buy either what? A desktop or a laptop, but there are 3 different types of desktop and 4 different types of laptops. So basically you add them. There is 7 different choices here, right? That's very easy. Now another principle is called the multiplication principle, and that is if one event can occur in m ways and the second in n ways after the first event has occurred, then the 2 events can occur in m plus n ways, right? So if something can happen in m ways and another thing can happen in n ways, then together there's m times n different ways this can occur, right? All right, so it's like if you have 3 pairs of pants and you have 2 shirts, how many different combinations can you put them on? 3 times 2 is 6, right? All right, so that's the multiplication principle. And so here is 2 skirts, 4 blouses, a sweater, and so she'll need to choose a combination of those. So use multiplication principle to find the total number of possible outfits. Well, that would be 2 times 4 times, so 2 skirt, 4 blouses, and 2 sweater options. You multiply them, you get 16. All right. So multiplication, again, principle can be used in many application problems. One type of problem involves placing objects in order, right? So we arrange letters into words. So let me give you an example. So if we have, let's say, 3 letters, and we want to rearrange them. Well, if you want to rearrange them, how many different ways can you rearrange them? Well, let's see. We have 3 positions, right? How many different do we have for the first position? Different letters. We have 3. How many do we have to fill the second position? Well, we have 2 because we already have used one of them. And then for the third position, we only have 1 left. So how many different ways can we arrange this? We just multiply 6 different ways, right? And this operation, as you remember, this is what? This is called factorial. So it looks like the answer to this is just what? The number of letters or things that you have, factorial. That's how many different arrangements. Now, arrangements of objects, if the order matters, is called permutation and has a notation P. So we say permutation of n objects taking n at a time that means you want to take all of them, is just n factorial, right? That's the formula. So if you have 5 books, how many different ways can you arrange them in your bookshelf? Well, 5 factorial, okay? So that's the number of permutation if you want to take all of them at the same time. Now, what if you want to take 2 of them? Well, if you take 2 of them, then you have only 2 positions. So the first one would be how many? We have 3. And the second one, we only have 2 of them to choose from. So that would be 3 times 2, which is 6, right? If you want to take 2. So let's write down all the possible ones. So you can take A and B, you can take A and C, and you can take B and C. And then the other way. You take B first and then A. You can take C and then A, C and B. So if the order matters, if you're looking for permutation, of n items taken R at a time, then we're going to see what the formula is. So here, the formula is going to be basically, looks like, you don't want 3 factorial, because that would be taking all of them at the same time. How do we do it? Well, remember we have 3 times 2, right? So we don't go all the way to 1 to do the factorial, right? It looks like we stop somewhere. Where do we stop? What's the last thing we consider? Well, if you take that into account, and the formula becomes n factorial divided by n minus r factorial, right? So n factorial is like n times n minus 1 times n minus 2 all the way to, you're going to end up with what? You're going to end up with n minus r, right? Now before n minus r, because you keep what? You keep subtracting here. Let me have more space here. And then all the way we get to 1, right? So before you get to n minus r, what number do you get to? Well, is n minus r plus 1. Because you have to subtract 1 to get to the next one, right? You see? How do you get to the next one? You subtract 1. How do you get to the next one? You subtract 1. Now, how do you get to n minus r before that? Before that, we were 1 more, right? So it turns out that we always, to this formula to find it, we always stop at whatever number of letters we have minus the number of arrangements, the number of items you want to pick, and then plus 1. So in this case, we stopped at 3 minus 2 plus 1, right? So we stopped at what? At 2, right here. 3 minus 2 is 1 plus 1 is 2. So it always happens. So so if that always happens, we always stop right here. Then this, we don't need n factorial. We need to get rid of the rest of this, right? We only need that part of it. So it looks like in order to get that part, we divide by what? N minus r factorial. Because n minus r factorial is basically the rest. So if we divide n factorial, this, by n minus r factorial, that part gets canceled, so we get the correct answer. So in the textbooks, you see the formula this way. So to find permutation, number of permutations of n items taken r at a time is given by this formula. Okay? All right, so let me erase all this and talk about an example. The professor is creating an exam of 9 questions. So there are 9 questions, right? From a test bank of 12 questions. So we have a test bank of 12 questions, right? We're taking 9 of them at a time. Question is, how many ways can she select and arrange the questions? So order here is matter. It does matter because the order of questions matters in a test. So this is a question of, we have 12 items, we want to take them none at a time. So calculator can actually calculate this for you easily. Calculator has this programmed in it. So what you do with the calculator to find this, you go put 12 there first, and then go to math and probability right there, and then you see NPR, you pick that one, and then put 9 after it. No, I didn't put NPR. Let me do it again. So math, probability, and NPR. There. And then we put 9 after it. We get the answer. It's a big number. Now, of course, if you were to do it by hand, you would have to put it in the formula, right? The formula is n factorial divided by 12 minus 9 factorial. And if you put that in the calculator, you get the same answer. Okay, so let's see. So it would be 79,833,600 different ways. That's a lot of different ways, right? All right, now, if you were to, it seems like, let me go back to that example of ABC. So if you want to take 3 numbers, right, and arrange them 3 at a time, and order doesn't matter for you, then the answer to this is just 1. So what is that? Well, that's combination. So arrangement of objects, if the order doesn't matter, we call it a combination. So what's the combination of 3 items taking 3 at a time? Well, that's 1, because we don't care about the order. If you just put them together as one group, that's 1 combination. If you switch B and C, it doesn't matter. It's the same combination. So there's only one possibility. But what about if I want to take 2 items at a time? Well, we can take A and B, A and C, B and C. Now, if we change the order, that doesn't matter, right? These don't count. Why? Because they're the same grouping of letters, but different order. And as far as combination is concerned, it doesn't really matter. So we only have 3. The answer is 3. So it turns out that basically what we have to do, we have to reduce the number of permutations by that many. And it turns out to be that. So you divide by r factorial. What is r? R is the number of items that you want to pick. So you have to divide the permutation, which is n factorial over n minus 1, n minus r factorial, by r factorial to reduce this number by that many. So that means this C is number of combinations of n items taken r at a time, which has 3 different notations. You can write it this way, you can write it this way, or you can write it this way. Parentheses, put the, this should be n, I just saw. That should be n and r. That's not correct. So that's n, right? Or, of course, the formula is that. So it looks like the formula for permutation, but just divided by r factorial, right? Now, if n equals to r, of course, we talked about that. If n equals to r, then, so for permutation, this is, I have to fix that. So this is C, and this is going to be r factorial here, right? And this is going to be 0 factorial, right? And the 0 factorial times r this is going to be 1, right? I have to fix that. I fixed it right now. It was mistyped here. So that's a C, right? And there's a R factorial here. All right. So that means CNN, not the news thing, but this CNN, and this is not a news thing either, NPR. So CNN is basically number of combination of n items taken n at a time is 1. And this, if you put n here, that would be actually n factorial, right? All right, so we got that under control. A fast food restaurant offers 5 side dish options. Your meal comes with 2 side dishes. How many ways can you select your side dishes? Well, that would be number of combinations, right? Because when you select your side dish, you don't care about order, right? So it doesn't matter in which order they give you the side dish, it's the same options. So that's the number of combinations. And that we can do with the calculator as well. So let's see. So with the calculator, we go to the same place. So I want to find C52. So I want to find this. C 5 items taken 2 at a time. So I put a 5 there first. Then you go to math and go to probability and go to number 3. And then put 2 there. And the answer is 10. Right? All right. And how many ways can you select 3 side dishes? Well, it would be the same. Now, here's think about it. It's something interesting. You have 5 things, right? Let's see, you have. Now, C of 5 taken 2 at a time seems like is the same as taking 3 at a time. How is that? Well, this is always happens. It is always true that if you put NR here, then this is N and N minus R, right? These are always the same. Now, why is that? Well, we think about it this way. If you want to pick these 2, right? Then at the same time, in order to pick these 2, what do you have to do? You should not pick these 3. So every time you make a choice, you're also making a negative choice. So it's a positive choice, you also make a negative choice. So when you take A and B, you're not taking C, D, E. So how many different ways can I not take, these items, right? Would be the same as how many different ways can you take these items. So that's why this is the same, right? So that's one way to think about it. And I have it here too. You can read it and see if it makes sense to you. Stop the video and read this. It's the same thing I just described. And they're the same. That's why they're the same. All right. So let's move on. Now consider, for example, a pizza restaurant that offers 5 toppings. Any number of toppings can be ordered. How many different pizzas are possible? Now, so far we have looked at combination problems in which we choose exactly our objects. In some problems, we want to consider choosing every possible number of objects, right? So for example, if you have 5 toppings, you want to pick the number of choices that we can have, either 1, 2, 3, 4, or 5, right? Or none. So all of that has to be taken into account. Now to do that, we're going to use this formula here, which is 2 to n. And it's called a set containing n distinct objects has 2 to the n subsets. So if you have a B, C, D, E, right? So suppose this is a set. Now, what about if you want to take 1 at a time, or 2 at a time, or 3 at a time, or 4 at a time, or 5 at a time, or none at all? So how many different ways that is possible? For example, we can have a set that has nothing in it. That's called an empty set. We can have a set that has only A in it. We can have a set that only is B in it, and so forth, right? Or we can have a set that has two items in it, like A and B. Or we can have a set that has A and E in it. Or we can have a set, right? Or we can have a set that has three items in it, A, B, C. Or, A, C, D. Or maybe four items, or maybe five items. Or how many of these do we have? Well, that is we use this formula to find it, right? So basically think of 5 items. We have 5 toppings, right? So every topping, you have a choice of taking that topping or not taking that topping, right? Taking it or not taking it. So you have 2 choices. For that one, you also have what? Taking it or not taking it. Taking it or not taking it. Taking it or not. Taking it or not. So together we have, you multiply, right? After you multiply, you get 2 to nth power. So that's how you figure it out. So it would be 2 to the 5th. In this case, would be 32 different ways these toppings can be chosen, right? Whether 1 at a time, 2 at a time. Maybe you have a pizza with only 1 item in it. You have another pizza, maybe it has 2 items, right? And so forth. How many different pizzas can be ordered using 5 toppings? 5 toppings, 32. Okay? All right. Now, sometimes there are some repeating ones. For example, let's say we have this letter, distinct. So it's got 1 D, but it has how many I's? Has 2 I's. It has 2 I's that are the same. And there are 2 T's, right? And there are 2 T's. And the rest of them are just single. So if you have a bunch of items, and let's say I happens to repeat twice, and then T happens to repeat twice, and D is by itself, and S is by itself, and N is by itself, right? If you get all that, and C is by itself, right? So now we have how many items? 1, 2, 3, 4, 5, 6, 7, 8. But it is divided into 2, 2, 1, 1, 1, 1. Right? So it says if there are n elements in a set, and R1 are alike, and R2 are alike, and so forth, right? Then how many permutations do we have? Now, if permutations, that means doesn't have to be meaningful, right? We just want to know the different arrangements. That order doesn't matter. For example, you can put DII, then put STT, right? And we're owing N and C. Here we go. So this is a permutation, but if somebody switches these two while you're not looking, well, you can't tell, right? Or switch these two. So we shouldn't really include those permutations in number of permutations. To take care of that, we use this formula. So instead of using just n factorial, we're going to divide it by all of these are R1 is 2, R2 is 2, R3 is 1, and R4 is 1, R5 is 1, R6 is 1, right? So we just take the factorials of these R's. The one that are single, you don't have to put it because 1 factorial is 1, so they don't count. So I'm just going to put the ones that are repeating. So I'll put 2, the formula, of course, is R1 factorial and then R2 factorial and so forth, all the way to RK factorial. RK is how many of these R's we have. So in this case, we're going to use this formula. So we are going to do 8 factorial divided by 2 factorial times 2 factorial. We don't have to put the rest of them because they're all 1 factorials, right? So there are 10,080. Now if you don't divide that, there are going to be a whole lot more, which actually they look the same, right? Because you can't tell the difference. All right, so let's do the last thing we want to do here, and that's binomial theorem. Now, in binomial theorem, remember x plus y to the second power is x squared plus 2xy plus y to the second. Well, there is a general, actually, formula that can help you find any of these, x plus y to the nth power, and n is an integer. In fact, there is another one you learn in calculus 2. Even if n is not a integer, is a real number, we can still do this expansion. Let's say it's the square root of 2 here. But we're not going to talk about that in this course. You see that in calculus 2. Here we assume n is an integer, positive integer. So if it's a positive integer, how do we expand it? Well, this has been around for a long time, for centuries. And Omar Khayyam was a Persian mathematician who thought of this. There were some Chinese mathematicians who knew that, and some Russians and different people all over the world knew about that. But this triangle in the West is called Pascal triangle. When I learned it in high school, we learned it as Khayyam-Pascal triangle. So I'm going to just name it that here. So what does this do? Well, it gives you the coefficients of the expansion that you need. So if you take, instead of x and y, I put s and f here. So if you put s plus f to the 0th power, you get 1. So the coefficient is just 1. If you raise it to first power, you get 1s plus 1f, and those are the coefficients. And if you get sf to the second, you get 1s squared plus 2sf plus 1f squared. So you see 1, 2, 1, 1, 2, 1. And then this one is 1s to the third plus 3s squared f plus 3sf squared plus 1f to the third. 1, 3, 3, 3. So to build this triangle is easy. You start with 1 and these ones, and then and then put 1s here and add the middle ones. And then put 1s here, and then add these 2, and add those 2. And then put 1s here, then add those 2, and then add those 2, and then add those 2, right? So you can build it as much as you want. This was known for centuries, and of course Pascal worked with this, and then Isaac Newton worked with it and came up with that formula in calculus 2 I talked about. So now what's the formula? Well, the formula turns out to be related to this number of combination thing. So notice here, let's look at this third power. If you just write, s plus f times s plus f times s plus f, and just multiply them, that's what you're going to get. So notice that you have one combination that has all 3 s's in it, and then we have 3 combinations that have 2 s's in it, and then we have 3 that have 1 s in them, and we have 1 that has no s. So if you think of 3 s's, right? If you think of 3 s's, how many different ways can you take all 3? Well, there is only one way. How many different ways can you not take any of them? There is only one way. How many different ways can you take 2 of them? Well, that would be what? That would be that, which is this number right here. So that means when you expand this, all of these have a structure of s squared and f, right? So how many of these are we going to have? This many, right? And then here, there is only one s, so that would be sf squared. How many of these are we going to have? We're going to have that many, right? So this connection was discovered, and this formula was invented. So that's the formula. So s to n minus r, f to r, and looks like it's a sum. It's a sum, so we use notation, sigma notation. So when r is 0, we get f to 0, right, which is 1, and then s to n minus 0, which is n. So that's the first term, right? So you see we get the first term. Let's say this is 3 here, right? So this is 3. This is going to be 3, and this is going to be 3, right? So we expand it like this. We start from r equal to 0. If r equals to 0, that would be what? C30, which is actually 1. So Cn0 is the same as Cnn is the same as 1. That's true. So C30 would be 1, so that's 1. And then s to 3 minus 0 is s squared, and f to 0 is 1. We don't write it. And then when r equals to 1, that would be C31, which is 3. And then s to 3 minus 1, which is 2. And then f to 1, which is that. And then when r equals to 3, we get C33. When r equals to, so we got 0, we got 1, and we got 2. When r equals to 2, we get C32, which is 3. And then s to 3 minus 2, which is 1. And then f to 2. And then when r equals to 3, we get C33, which is 1. And then s to 3 minus 3, which is 0. So s to 0 is 1. We don't write it. And then f to 3. That's how we expand it. Now, so with this formula, this could be 300. We can still do it, right? It just takes longer. So it's a pretty powerful formula to expand these. So we write it sometimes this way and sometimes this way. So that's the expansion. So if you want to expand x plus y to the n, and that's what it looks like. You can write more of them, but that's what they look like. Again, this is the same notation as what? As that, right? Which I have here. Okay, so we can expand these using the formula, right? So remember the formula is a sigma what? Sigma C n r, right? And use r or k, doesn't matter. Let me use k. Oh, let's do it. K, right? So k equals to 0, right? 2n, right? And this is x to n minus k, and then y to k, right? So when k equals to 0, what do we get? Or when k equals to 0, we get Cn0, and n is in this case 5. So let's put 5 here, right? Because n is 5 here. So when k equals to 0, we get C, this is 5, 0, x to 5 minus 0, and then y to 0, which ends up being what? That, right? And when k equals to 1, what do we get? We get C5, 1, x to 5 minus 1, y to 1. So that's that part. And if you put this in the calculator, you get 5. And so forth. Let me do the last one. What is k equals to 5? Would be what? Would be C5, 5, x to 5 minus 5, and y to 5, right? So that gives you this right here, and this is actually 1, right? And that's it. So that's how we expand these things. And this one is a little bit trickier because now we don't have just x and y, we have 3x and we have the y, right? And then y is actually, you can think of this as plus negative y. So assume that the second one is just negative y and the first one is 3x. So we're going to think of this as 3x plus what? Negative y, and treat it the same way with that formula, right? except you just put 3x and this instead of x and y, right? So that's a little bit trickier. You just have to simplify it. You have to be careful when you simplify with the signs and multiplications. It ends up being that, right? All right, so I think we got this under control. One more thing, let's see. Now, what if you want to raise, let's say you want to raise this x plus y to 300th power, but you don't want all the terms, you just want a specific term, right? Now, to do that, then think about it. So, for example, the first term of this is what? Is Cn. So when k equals to 0, right, we get C0 x to n minus 0 y to 0, right? Now, and the next one is going to be what? The next one, let me get my eraser here. There you go, I got it. So, so think of this one right here. So if it's 0, think of it as 0 plus 1. So think of this as 0 plus 1 term, right? Because it's actually the first term, right? So this is the first term of this expansion. When you expand it, what's the first term? The first term would be what? Would be this, right? That would be the first term. So that's the first term. But instead of calling it first term, I'm going to call it 0 plus first term, right? 0 plus first term. So when I got 0 plus first term, I have to put 0 here, I have to put 0 here, and I put 0 here. Now what about if I want happy face plus first term, right? Then I have to put what? I have to put happy face here, right? I have to put happy face here, right? And I have to put happy face here. Those are happy faces, but can't tell. There. These are happy faces, right? So what if I want r plus 1 term? R plus 1 term. Well, then I have to put r here, and then r there, and r there. And that's the formula right there. See it? So if you want r plus 1 term, r plus 1th term, so for example, if r is 4, what's the 4 plus 1 term? That means the 5th term. Well, to find the 5th term, then you have to think of it as 4 plus 1, and then take 4 and put it in these places, right? So that's the formula to find the what? R plus 1 1th term is given by that. You don't want to expand the whole thing, you just want that specific term. So here is an example. So let's say we want to raise this to the 16th power without fully expanding it, of course. That would take forever to do. So what do? We are going to, so we want what? We want find the 10th term. So we're going to think of 10th term as what? As 9 plus 1 term, right? And then take 9 and put it in these places, right? Now instead of x, of course, we have to put what? This x. And instead of y, we have to put 2y, right? So it's the same structure. We put 16, n is 16, 9, x to 16 minus 9, and then y here is 2y to 9. The rest of it is simplifying. Just put in a calculator and simplify it. So that would be the 10th term of this expansion. That's what's going to be. All right. So I think we got to the end of the video here. So what I'm going to do is I'm going to go back here and say bye to you until next time we meet. I'm not sure when that is, but in the virtual meetings we can meet. So take care of yourself. Remember, this is the last video of the course. So I see you in the virtual meetings. Take care of yourself and others. Bye-bye.